Hi all, my name is Vladimir. It's midnight in Moscow time zone, and you are watching the Nightly Code channel. As you remember, we are improving the Scarlett driver for Linux, and today probably we'll switch about the context and look into some interesting case. Probably I need to demonstrate the case of today's theme that we will touch in our stream. I'll just move it here, and we will see that Anfa has recently published a video when he reviews the Scarlett 2i2 Gen 3 device, and probably it is one of the best reviews for Linux users. But I was watching this video and I have left a comment where I was just offering the people who are reading the comments to visit my channel and watch the work that I do while developing the driver code for the Scarlett Gen 3 device series. Here is the comment. Anfa has pinned it, so to make some promotion for me, and thanks Anfa for that. But that seems that there are still some people who don't understand the things that I'm doing on my channel. So you can read the comment that the man that is also from Russia as me that doesn't understand what I do. Then we had a pretty large discussion where I was just trying to explain the things that are still not available in the driver, and finally we got to the question where I just asked him, does he know about that the Linux driver doesn't support some features like gain halos for the device, and does it allow to set these gain halo settings for the audio interface. And the man has offered me to buy the LED strip. Wow, what's that? I don't want a LED strip. I want to control my device with the full availability to set all the changes that original software allows to do. Why I need a separate LED? What's LED strip for $1 from AliExpress? That's pretty crazy. I probably think that the man didn't even understand that I was trying to tell him. But anyway, finally he found that I'm the troll and that the original software doesn't allow the color changes for LEDs in the device. And today I think we will do the following thing. We will write the implementation for changing the colors of the LEDs of the device. Probably I think I need to demonstrate how the gain halo work. We just need to connect the device to the virtual machine with Windows, and it is already connected. And here's the gain halo settings section, and I'll just take the camera and move it and show what's happening. So Let's do that. I'll just take the camera and put it here. Probably you see what's happening here. I just need to check. Yes, that's pretty good. Okay. And let's try to change the color of the LED. So I'll just click here. And we see that the LEDs became of the color that we are currently setting to them. So there are 8 colors available for changing and 3 levels. So the good level is probably below the -6 decibels. There's a yellow level within the range from -6 decibels to 0 decibels, and clip for the level over the 0 decibels. So if I just make, and you see the same thing works for the Scarlett 2i2 device, which is on the top of the 18i device. I won't just show this for 2i2 device since I am running the streaming through this device and I don't want to switch it from Windows to Linux. And I'll just do some pops on the microphones to see you that the color of the of the input changes depending on the level. So that's it. So the phase is that there is no settings for the colors of the LEDs for the device is false. So I can just take the my OBS Studio, switch to this, and say ta-da-da-dum, ta-dum, 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 bum, bum, ta-da-da-dum, ta-dum, ta-dum, pew! And then up the stream. Now, we'll continue the stream and we will explore what's happening with the device. So I'll put the camera back to the top of my monitor and we'll continue. Oh, I need to correct it a bit. All right, seems to be okay now. So I'll close the browser since we don't have any need for it now anymore. I need to switch a bit my workspace. I'll just move the all the desired stuff to the working space there where I'm just used to work. So there's nothing extra special here, so that's good. And we will do the usual stuff. We will just disconnect the device, perform the protocol dumps, and then we will explore how the gain halo settings work. So I'll disconnect the device and launch the USB pickup tool to grab the gain halo settings. So let's do this. We will launch the USB pickup SIMD.exe and specify the hub and specify the file name that will be Scarlett 18i8 gain halos pickup. So that's pretty cool. Now we will just connect to the device. Wait a bit. Here's the setting. And now we are ready to switch gain halos. So we go here. And we'll switch the good settings first. So we'll do this. And probably we'll switch from green to blue probably. Or yes, we will switch from green to blue. This will switch from yellow to green, and this will switch from red to probably white. This is not the white, this is the pink color. So, and we will do the back thing. We will switch the colors back. So to green, to yellow, and to red. So this is pretty enough. We can stop the USB pickup now and download the pickup file and check what's happening there. So here's the C USB pickup, C program files, USB pickup, Scarlett 89 gain halos file, and we'll put this here. And now I'm ready to change the directory to C to here. This is the Focusrite Scarlett back parts, and here there's a reverse eng folder, and we have the file here, Scarlett 89 gain halos. So let's do the run sh and specify the name of the file. FF Scarlett 89 gain halos pickup. That's ready. So let's look at the contents of the file. We will just do this by file open, and open here in our Scarlett back ports, debug driver, or reverse eng, and the clean. So it hasn't already been opened. We'll just reload it. And now we are ready to analyze the file. We'll create a new file to record our observations and put it at the right. So let's look what's happening. Here's the device initialization sequence as usual. Here's happening something. Here's the get data, and then we will probably see that set data events, which will be frequent. Okay, here's the set data. We see that the first change was made was the value at the offset A1 from 0 to 2, then from 3 to 1 at the point 82, then at point A3 from 3 to 1, from at the A4 from 3 to 1, and at the A5 from 3 to 1. So Let's write it down. So the hexadecimal A1 from 0 to 2, and A2, 3, 4, and 5 from 3 to 1, and so on. A2, A3, A4, and then A5 from 3 to 1. Okay. Let's look then what's happening then. So here's our first change, and let's look next. So then there is a series of changes at the A2 from 1 to 2, and again A3 from A4 and 5 from 1 to 2. That means that the color of the LED was changed. So the colors of each output are controlled by the individual color of the that can be set to each there is a possibility to set the individual color for each output, so we have changed from 1 to 2. Then we probably have changed from 2 to 1 back. Okay. Oh, sorry. Then we already have it. Then we have switched to from 1 to 2 back. And so we have, so we were floating from one value to another value. So there was a series of changes. And there was an A8 change from 2 to 6. And then there was the change from for A1 from 2 to 0. So I need to scroll back and see again. Was there the change of A8 asset previously? Now there's just 9D. Then A1 from 0 to 2. And then only A2 to A5. Then from A2 to A5 again. Then from A2 to A5. Then there was an A8 setting and A1. Okay. Then what we have did then. We have set A1 back from 0 to 2. We have set the A2 from 6 to 2, A3 and 4, and then 5 to this. Then we have set the A7 from 6 to 2, from 3 to 2. What is this? And have changed the A1 from 2 to 0. So, I think the A1 byte is responsible for turning on the lightness of all LEDs to the color that is specified at the address A2 to A5. And after that, we have then A8 and A7 and A6 and 8, 7, and probably 9 to specify the levels. So probably we'll look how the next level update will look like. We have set A1 to from 0 to 2. Yes, that's the usual stuff. Then we have set A2 to A5 to the desired color. And then after that, we have switched the desired color to 5. And then from 5 to 7. And then we have, what do we have then? And then we have switched A6 from 1 to 7 and switched A1 from 2 to 0. So there are bytes A6, A7 and A8. A6, A7, A8. These bytes are probably responsible for the colors, the level colors. The values from A1 to the A1, the light control, and values from A2 to A5, the actual color of the light. A6, A7, A8 are responsible for the level control. So let's look next. Then we have switched from 0 to 2 and set the value from 0 to 1, from 1 to 3, 2, and finally ended up with the value of 2. So probably red is 0, green, there's an additional color. Yellow is 1, green is 2, and so on. So the numbers are growing by 1 from 0 to 7 here. So let's go back. So we have switched the A8 for the value of 2. Then we have switched the probably A7 to value of 3 from 2 to 3. And probably the A6 we have switched to value, to which value? To 1. To 1. I don't know why it has scrolled. Yes, we have switched from... probably I'm not pretty correct. Probably there was an RGB color naming, so we'll just look at the notes with that I have previously written. We just know that the A8, A7 and A6 are responsible for the colors. And the only thing left is to properly understand the coding of these colors. So I'll open my notes. So here's, where is it? Config space. And look at the gain halo settings. A6, gain halo colors. And the A2, immediate gain halo LED colors. 1 byte per input. Each byte contains RGB components, 1 bit per component. A1 is the gain halo value. 2 enables the immediate gain halo values. So it allows us to make the LED lighting with that color which is specified from starting from the offset A2 to A5. And the A6 is the gain color settings, 1 byte per level. Each byte contains RGB components, the order of components: clip color, pre-clip color, and good color. So this seems to be similar to what we have explored in our protocol dumps. The only thing left is to look into the driver, which I have previously written, and take the code from this driver and look what's happening. So let's do this. I'll open my version of driver and look what's related to gain halo. Gain halo levels. Probably key, that's gain halo LEDs max. Okay. Gain halos count. Okay. Gain halo flag. Gain halo custom. Okay. Gain halo LEDs and gain halo levels. Okay. Gain halo LEDs max. What was this? The constant? Okay. And gain halo levels 3. Okay. What's next? So there's a gain halo enable config and gain halo LEDs. and gain hello levels. Okay. Also, I need to explain that the configuration of the professional devices like 8i8, 8, 18i8, 8i6, and 18i20 differs from the configuration on the low-end devices, since the low-end devices have a less sized configuration space, and the gain halo is a bit working in another manner. So gain halo enable flag bit 1 enables immediate values for gain halo. Gain halo LED color 1 bit per each RGB component. Gain halo colors for corresponding levels. 1 byte for per RGB in order. Clip, reclip, and good. So, and probably there was some special case related to gain halo. I need to learn what's happening then. So here's the Scarlett solo info, and gain hello's count are 2. Okay. There, gain 3, gain hello's count is 2. 2. 4i4, there's no information for me at this moment. The 8i6, I also don't have any information. And 18i8, gain hello's count is 4. And we need to look how the driver works with the settings. So here's the actual mapping of how the gain hello colors are set. So we have the off, red, green, amber, blue, pink, light blue, and light pink. Red, green, amber, blue, pink, light blue, and light pink. There should be 8 colors, probably. We need to look again. 1, 2, 3, 4, 5, 6, 7. 7 colors, not 8. 7 colors are available, and 0 means that there is no light. Oops, what's happening? Probably I need to disconnect the device and go back and connect again. So we see that there is 7 colors available, not 8. And if we set 0, then there are no colors at all available, and then the LED doesn't work. So I'll switch it back and launch the Focusrite control. Yes. Oh, that's something strange happening with the device. Oh, that it's it's working wrong. It didn't read anything from the device. That's strange. Probably I need to reconnect the device. and then relaunch the Focusrite control, and now it's working pretty well. So as we see, there are 7 colors available, and we need to explore. If the least significant bit is 1, then the red is 1. If there is green, then the green is 2 and the blue is 4. So 0, 1, 2, 3, 4. Yes. So probably we need to do the following thing. Also need to check what gain halo custom control does. So it just read the gain halo custom value. Probably it should be protected with a mutex to not read invalid values. And also we can get the level control value and get the level control and the LED control. Okay, and custom control put. And there is the comment. You will set the comment and we enable it. And the level control put. And the LED control put. So probably in my version of driver, we were able to enable this selection and then switch color and then update it. So probably we need just to update the value of the gain halo. We don't need to light up the LEDs. So probably we need to work with what? There's a clamp. Gain halo levels and gain halo LEDs. We just need the gain halo levels, probably. Let's check again. Yes. So we just need to write these 3 values to the proper place, and probably that's all. So we need to take our mixture driver and copy the constant there. So let's do this. Where's the... I need to find the proper place to place it. Mux max. Don't like the constants jumping from left to right. I just want to see the constants as a table, not like some jumping code. So here, mux max. Where's the mux max? Oh, here's the mux max. And we can just take these and define the gain halo levels here. Okay. Then we need to define the gain halo levels variable and go to the top. And write it down here. Probably here. Mr. TXD, hello. I don't see my previous comments here. That's strange. Where's the stereo settings? Stereo switch, yeah, here it is. So direct monitor switch. And so on and so on. Oh, so we'll keep it here. I'll not set the comment, and we need to probably to specify the controls or not, or don't need to specify the controls. Don't need to store them. Okay. There's mux and mix settings and mix mutes that should be implemented in the future. So we have the gain halo levels and need to see how they are adjusted. So here's the gain halo color enum control info. So we need to find some place where we can place this, probably at the end of the file where there are controls. Here the main meter controls, and probably we can add MSD controls, and after MSD controls we can copy the contents of the new driver, of my version of driver. So we need to Scarlett to gain halo color enum control info here, and gain halo switch controls, the comment. We'll leave the comment here. So, and we need to work again. We need to work with the gain halo levels. So this is not our case. Gain halo level control get. So here's the gain halo levels, right? And the gain halo level control put. And this code, we need for this code too. So probably we need to add the mutex lock here. And add the mutex unlock here. And we need to define the information about the control. So level control, here it is. So we have the description of the control. We have the Scarlett to USB set config call, but the config depends on what we are working on. So Scarlett to USB set config. We need to look the data structures that it is used to use. So This is not that what we need. Offset. We need to read the offset, and where we do get the offset. So config items. Yes. So we take the config item, check the size, and do the stuff. So we need to look at the config item definition here. So we'll switch here and look for the config item. So here's the Scarlett config the devices without the mixer, solo and 2IT GAN 3 device. And there is a devices with the mixer, so GAN 2 and all other device GAN 3. And the only config is that, and we need to define the proper offset for this switch here. So we need to go to Scarlett to config air switch, and there we need to define this gain halo settings. Gain halo levels. That's pretty enough for us. 14 and 15. And that these gain halo levels offsets here. So gain halo levels. For the Pro configuration has the following setting. This is for the Pro device. And for the low-end device, there is the gain halo levels with such setting. It has an 1A offset. Okay. So probably we did all the things right, except that we need to define the controls at this moment now. So we need to place the correct creation of the controls. So let's look where these controls are created in the old version, or in my version of driver, which is written before the latest changes came into the Linux kernel. So gain halo levels. Also, we need probably to define the gain halo settings. And switch and add the flag that the gain halo is supported. So U8 gain halo indicates the support of the gain halo color changes. So we need to write down that the Scarlett device has the gain halo setting at least 1898 again too, Again 3 device 8920 also has gain halo, but the gain halo behaves in a bit another manner. Since the A8920 device has the level meters at the front of the device, gain halo actually shows the level that the level meter shows on the front of the device. So if we could control the gain halo for 8920, then we could just set the desired value to the output meter, but that doesn't have any sense. So we just disabled the gain halo settings for the 8920 device, since it's not necessary to do to apply gain halo settings. So we just need to watch the Gen 3 device 898 and set the gain halo to 1. And set for the solo and for the 2i2 device the support of gain halo too. So that's that. When I will have the 4i4 and 8i6 devices, I probably will look at them too. So, but I cannot say that the code will behave correctly with them, so we'll just not support this for these devices, this feature for these devices at this moment. So the only thing left is to see how the gain halo level controls are created. And copy the code. So here's a separate function that allows us to add gain halo controls. And I don't see the LED one. That's not that. Where are the names? Oh, here are the level names, and level names are inlined into the top of the function. Okay, so we need to find the place where we can put the function that will add the gain halos. So probably read config, USB init private, find FC interface, count mux IO, private free, and get level. Okay, and where are the controls created? So probably need to find add meta control. Okay, here it is. Oh, it is put to the place where the control is actually defined, so I can just put this function here. And we need to copy this code and tune it a bit to remove the unnecessary functionality that I have previously implemented. So also we need to ensure to look at we don't need to look at, we just need to look for the support. So Scarlett 2, we need to look at some another function, line out controls, for example. So Scarlett 2 data, we don't have the word mixture data, we just have the data, and this is true for all other functions. Yes. Um, so we also can do what? Probably we don't need this. We only need the gain hello levels. We have the name for the gain hello. Oh, do we actually need this? Restate of custom colors and add colors. We don't need this code. This is LEDs. We need the levels only. Custom color settings. We also don't need this. And here we need to check that the gain hello is supported. So if info gain hellos is less than 0, probably this. No. So just gain hello. Probably I need to write gain hellos. And probably that flag should be renamed to gain hellos. Yes. Okay. So if we have no gain hellos, then we just quit from the function. Then, but otherwise, we just loop through the number of gain hello levels and the control. We read the gain hello levels, clamp them to the value from 0 to 7, and do the usual stuff. And also we add the control, but don't remember that pointer to the control since we don't need this. And the only thing left, we just need to call this function from the driver initialization code somewhere at the bottom of the initialization code. Probably here. Check the code, check the execution for errors, and leave the driver. So we need just to put the add gain hello level color control for the device. And probably that's all what we need. I think we need to launch the compilation and check what's happening. Oh, that was my child playing with my keyboard. So let's do this. Make J8. Okay, there was an unused variable. We can remove it. So let's do this. Which line? The line 4705. Okay, that's not a problem. We'll do this. And recompile the driver. Okay, that seems that the driver has been compiled correctly, and we can now connect the device to the driver and check for the changes. So let's disconnect the device from the virtual machine with Windows and connect the device to the virtual machine with Linux. Okay, and let's do this. We need to find the messages where the gain hello initialization was performed and find them. So since this is the last, I don't see any message about the gain hello, but probably it should be. Let's look into the driver code, and we have the gain hello levels message, but currently I don't see it. I don't see it. Hmm. Probably I need to add the extra message, and probably that can be the problem of the Scarlett to get config. So I'll add message here. Run Scarlett to USB get config, and here that gain hellos are not supported. And we will check again and add the message that the gain hellos have been initialized. Probably that will be that can be my mistake from my side. Also, I need to ensure that we have the gain halos setting to set to 1. Yes, we have. So probably we need to. Oh, I I forgot to reload the driver. Right. So anyway, we need to recompile the driver, reload it, and then check what's happening. Oh, there's a mistake in the code. So yes, I'm a bit sleepy today, so probably we'll end up quickly with the stream today. We will become the gain hello settings correct or working, then we'll end up today. So there wasn't then error in the code, and probably I have already corrected it. Yes. So I have already disconnected the device, all right. And now we'll just reload the driver. Copy the new version of driver to the modules tree. And now we're ready to connect the device and watch for the changes. So let's do this. Okay, we have the gain halo levels 0 set to 1, to 0 and to 0. The A6 bytes 1. Why 1? Request chunk, rec offset A6, rec bytes 1. We have requested the only one value, and that's not good. Seems that the Scarlett 2 USB get config behaves in another. Oh, gain halo levels. Scarlett 2 USB USB get config behaves in a bit another manner than I was expecting. So we have mixture, Scarlett config gain halo levels, Scarlett gain halo levels, and gain halo levels. So I need to check how the Scarlett USB get config works and what we have written to the levels gain. So where's our configuration space descriptor? Halo. Gain halos, gain halo levels. Where are the configuration space settings? I don't see them. Oh, here are the config count and config items. So size 1, and here's size 1. Size 16. Probably I need to set the size to 3, but I need to ensure the Scarlett to USB get config function to watch the get config function to ensure what's happening. So we have the size, and we perform the Scarlett to USB get. And how does the size work? Value, config item, offset, value 1. Then unpack from value into buffer. What? Oh, that's not that way that I was expecting to the get USB get config should work. So the previous version was just calling this card to USB get and specifying the config size item multiplied by the count. It's pretty strange. I need to think how to change the code. If config item size is greater or equal to 8, then we just perform the Scarlett to USB get, and I think I need to take the part of the function and just perform the direct read of this property. I think yes. So I need to go back to the levels, to the again hello settings. This is at the int. And I don't like this card to use bigger config, and there are two ways. Probably we need to specify the protocol for the parameter. I need to watch the Scarlett to config items again and look. Size 8881. So the MSD switch, we do the read of 8 values. Oh, or is it in the bits? Ah, I know. Now it is working with the bits. So actually we have the size converted from the bit count, and we request the size in bytes. And if size if of value 2, we perform the Indian switch. Otherwise we don't. Okay, I think I need to set the value 8 by 3 is 24, and probably this will solve our problem. And I don't need to do some extra changes. So I think this is pretty enough. I just need to recompile the driver and check what's happening. So we'll disconnect device, compile the driver. I probably need to ensure that I have saved the configuration and make J8. And also I need to check how the value is set in my function, how it is committed to the device. So I need to look at again hello again. Oh, we have an index specified, so there is a set config. I think I need to add the bookmark here to not to lose the code anymore. So here's the get config call, and we need to check how the set config work. Let's look. If the size is greater or equal to 8, it is divided by 8, converted to bytes, and the offset is computed as an offset plus index multiplied by size. Okay. Now that's clean. That should work. The only thing we need to check how it should work. So I think we have already the driver compiled, and we need to replace the old version of the driver, and now we're ready to check. So let's do. Okay, we have the gain hello level set to 1, 3, and 2. That means that the color red is set to the clip level, the yellow color is set to the pre-clip level, and the good color is set to the green. Yes. So we can launch the also mixture control and look for the gain hello. Oh, here it is. LED clip color, red, LED good color, green, and LED pre-clip color, amber. So we need to check how it does work. Probably I do the following thing. I will just take the jack connector, put the signal, send the signal from my current device to the 89 device, and look how the color will change. So here's the jack connector. So we have the black and red, and probably I'll take the black one, connect the black one to the output of the device. And connect another black jack to the input of the device. I'll test the fourth input since it is the nearest one. 1, 2, 3, 4, 5. Okay, and now I'm ready to launch some LSP plugins, oscillator. Oscillator mono. Okay, and we're ready to ship the signal of this device to. Probably I need to set the amplitude to minus 12 decibels. So if I just route it, you will hear it. So here it is. I probably need to make it less loud. So I will set minus 18 decibels. And now I can also connect this oscillator to the output of my device. Oh, it is already routed, so I can just crank up the monitor knob to send the signal to the device. So I'll take the camera and show. So I need to ensure that we have properly set up the camera. There are too many cards. Okay, so now I'll raise the monitor output. And we have the green color shining. Okay. Now let's go back to the Scarlett mixture and try to change the value. As you see, when I'm talking, my level of the speech also affects the LED, so we'll just look at the behavior of the mixture driver. So let's change the green value, good color, to something else. Is it working? Also need to look at the driver changes. So red. Nothing has changed. Green. Amber. Blue. Nothing has changed. Okay. Let's try something else. Raise the volume. Off. That's working. Red. Green. Amber. At least one property is working. The clip color is working. That's good. The good color. Nothing. And the pink color, nothing too. So it seems that we have broken the settings for other colors by setting the clip color. So probably that's something wrong with our setting. We need to look again. So I'll just disconnect the oscillator or mute it. I'll mute the oscillator and go back to the development. Alright, we have found that setting the red level is affects the color of the signal, but all other values are not working at this moment. So we have did something wrong, and we need to find out what's wrong in our code. So let's look again at the getting hello control set, control put. What's happening here? So we get the index. We can look at the log, what's happening when we change, for example, the value of the good color. We get the Scarlett to mux source in still get gain hello level ctl get, and we have the put from for index 2 to value 2. This is the good, and it has the index 2. The pre-clip has index 1, and the put also has the index 1. So the driver becomes the right value. The other problem is that it seems that it is not setting the value in the proper way. Again, hello level control put. So let's look at this. So we have set again hello levels index value, and we update the value by the specified index. Maybe the index should be multiplied by the 8. So let's look. Again, the scar2 USB set config. Item size. Set the configuration parameter data. So what's happening here? We have the size set to 24. So the offset is computed as the offset plus index multiplied by size, and the value is of 1 byte size. Then we compute the offset. We have the offset, we have the bytes settings, the number of bytes to set, yes, and value which we actually want to set. Then we do the scar to USB request when we ship the offset in bytes and the value. And then we trigger the change activation, the activation of the change. And that seems to be all. Data comment. We need to see that the data comment is also triggered here. Data comment 11 and data comment 9. Data comment 9 switches the mode, and data comment 11 applies the gain hello settings. So that seems to be pretty right, but that's still not working. I think I need to dump the packet which is shipped to the device, and look what's happening here. So I'll do this and dump the packet. Offset bytes value and write it here. Oh, okay, this is already int, so I don't need to cast it. So we ship the USB audio info and Scarlett to USB set config. Okay. And now we need to ensure that the driver ships the right data and actually look what's happening. So let's disconnect the device. Rebuild the driver and look into logs. Okay, we have reloaded the driver and now we're ready to connect the device. So let's do this. Okay, we see that the gain halo levels for 1 and 2 have been set to 0, and actually that's not working at this moment. So we need to tune the settings again and watch what's happening there. So we see that the LED color is off in our settings, and that's pretty right. So let's do set to red. And we see that Scarlett 2 USB set config updates the AC value. It updates the AC value, but we need to update the value A7 or A6. A6, A7, and the A8. That's something probably wrong with the offset. Okay, let's look into the LED clip color, which value will be updated. A6, that's right. The pre-clip, the A9, that's wrong. That's wrong. And let's look into the function, how the index is computed. Gain, size, offset, index. Index multiplied by size. Oh. So, for me, it's much easier to just... How does it work with the arrays? USB get config. How does it deal with arrays, or doesn't it ever deal with arrays anymore? Or didn't it ever work with the configuration? So Scarlett to USB get config. Make sure config item number, count, buffer. Okay. I think I was requesting the value in proper manner. So get config, make sure item number, count 3, and gain hellos. Probably I need to just set to 8 the parameter to value 8, and it will work as we expect. So we need to find our definition and set from 24 to 8, and that will work as we expect. 1 byte controls the value, so probably this will work right now. So let's do the compilation again. And seems that we have solved our problem. We only need to check. Okay, let's reload the drive. Oh, it's in use. I need to disconnect the device. And after I get the message that the device has been disconnected, I just reload the driver and connect the device again. So let's look into the logs and check what's happening. Okay. We see that the gain hello levels are set to 0, 200, and we need just to check that the gain hellos are working properly. So I'll just set the where's the pre-clip. I just need to check every configuration. So let's switch from green to red, and we see the A6 offset. All right. Then pre-clip we need to see A7 offset. Amber. Yes, the offset is A7, and the good color is green, and the offset is A8. So that's properly working now, and we now can ensure for this by just again looking at the level by sending the signal to the input of the device and looking at the LED indication. So I'll do this. Here's our device. Probably you see it. I need to ensure. Yes, here's our device. And now I will raise the loudness. Ship the oscillator signal and raise the loudness. So here's the good. And let's look how it will change. Good color, amber, blue, pink, light blue, light pink, and that's all. That's working pretty well. So let's make, for example, it being the blue. So let's see at the pre-clip color. I'll just raise the loudness. Here's the pre-clip, and we will change it to probably pink. So we see this. And let's set the clip color to something like light pink and raise the signal. Here it is. So let's look again at the levels. So gain halos are working now properly, and that's good. I can shut down the oscillator. Oh, and return camera back to the top of my monitor. All right. Seems that we have did a good job today. We need just to commit the changes. I won't check the behavior of the driver on my 2i2 device since I need to switch it. I probably do this after the stream or the next day. But at this moment, our task has been solved. We have implemented the switching of the gain halo colors, and the only thing left is that we need to commit the changes to the Git and push them to the upstream repository. So let's do this. I need to find. Who am I here? Oh, I'm just a regular user. I just need to copy the driver. And check for the differences. So Git status shows us that we have only one file changed, and then we will just do the git diff and look what has been changed. So we have just updated the placement of the constant values. That's nothing special. We have added this flag that indicates that the device supports gain halo settings. We have added the gain halo levels field that stores actual value of the gain halo level. We have added indication bits that the gain halo is supported by the solo device, 2i2 device, and 18i device. We have added additional constant that allows us to specify the location of the gain halo bytes in the configuration space of device, and have there specified this configuration space location for the 2i2 and solo devices and for the pro level devices like 18i device. What's happening with the 4i4 and 8i6, I don't know at this moment. Probably I need at least protocol dumps. At most, I need the device to test. So I have added some additional information about the configuration change. And we have added the functions that allow us to control the state of the gain halo switches. And added the function that initializes the gain halo controls to the driver in the initialization function. So that's pretty clean change, and there's nothing to review anymore, and we just need to commit and push the changes. So we will do the git add mixture Scarlett into C, git status, git commit with message. What we will write? Edit support of gain halo color change for solo 2i2 and 18i8 GAN3 devices, and git push. So that's all. If you have any questions, you may ask them in the chat. I'll try to answer since we have some time for it. I also want to thank you for donating the project, since every donation helps me to get closer to purchasing the new Scarlett device for testing. At least I need 2 devices. This is the 4F4 device and the 8i6 Gen 3 device. I'm also thinking on purchasing the Clarity device, since probably it will be also controlled in the same way as the Scarlett, but there is no confirmation at this moment. But if we look at the driver installation path, we'll find something interesting probably. So I'll go to the disk C, program files, Focusrite control, server, resources, devices. And we see that the Focusrite control also allows us to change the settings of the Clarity 2 pre, 4 pre, and 8 pre devices, which are USB 2. And there is an XML configuration with mappings, and probably it behaves in the same way as the Scarlett. So I think this is a good probability that the Scarlett driver will work well with the Clarity devices, but there is no confirmation at this moment. But Clarity devices are also interesting for me, so probably I need to look at them, or at least purchase one of them. But there are 2. I forgot the word. They have too much high price. We visit the if we, for example, visit the music store. If we visit the music store, for example, and write the Focusrite Scarlett, then we see that the price for the Clarity Plus 2 Pre, this is the new series of Clarity devices. The price for the Clarity Plus 2 Pre is pretty high. This is €489. Probably for the Russian country it is a bit less without the value added tax. Where's the Russian? Here it is. And for the Russia it is a bit cheaper. Yes, it is a bit cheaper since the value added tax is removed from the price, but still it's pretty high price, and I cannot allow me to purchase this device just for experiments at this moment for my own money. So if you are ready to donate, I will purchase the device. And of course, the Clarity Plus 8 Pre has also too high price, like an unused guitar or some new guitar. Anyway, what can I say at this moment? We will continue the development of the driver. uh, I think we'll go back to the routing and other settings of the device in the next stream. But the today job is completed well, and we can stop at this moment. If you have, I see that you have no questions, and probably that's all. So, see you soon. I think we will continue our streams the next night from Friday to Sunday to the Saturday, from Friday to the Saturday, and we will work in the next stream on the probably on the level of the volume level controls, since they are interesting for us at this moment, and they are highly bound to the output routing. So that's all. And I'll do some summaries about the job that I did this Tuesday, about the changes related to the mono to stereo switch. So I think now I'm ready to say to you goodbye. Please subscribe the channel, set the thumbs up, click on the bell to get new notifications. Recommend the channel to other your friends which like to watch such videos. And bye bye.